Welcome and thank you for always joining us. We are looking at K.c.s.e 2022 Paper 1, question number 18. This is section B, and the question reads, a shot put is spherical and has a mass of 7.26 kgs. It is made up of a metal with a density of 6.93 grams per centimeter cubic. A. Determine the radius of the shot put. Correct to 1 decimal place. We have been given the mass, and the mass is 7.26 kgs. If we multiply this with 1000, we are going to have 7,260 grams. Since we have the mass, and again we have the density as 6.93 grams per centimeter cubic, we can get the volume. And we know volume is given by mass over density. Mass is 7260 grams divided by 6.93, and this one gives us a volume equivalent to 1047.6 centimeter cubic. Remember, we have been told that the shot put is spherical in shape, and therefore we know to get the volume of a sphere, we take 4 out of 3 pi r cubed, and this one is the same volume as 1047.6 centimeter cubic. We replace that. We are going to have 4 out over 3 times pi is 22/7 as it has been given, times radius cubed, and this one translates to 1047.6. From there we proceed. 4 times 22 will give us 88. This times this will give us 21, r cubed being equal to 1047.6. From there we can now move. If we multiply by 21 on both sides, 21 and 21 will cancel, such that we have 88, r cubed being equal to 1047.6 times 21. You get 21999.6. If you divide both sides by 88, we remain with r cubed being equivalent to 250 approximately. If you want to get the value of r, you take the cube root on both sides, and therefore r is going to be the cube root of 250, giving us 6.299. But correct to 1 decimal place, the answer is going to be equivalent to 6.3 centimeters. Remember to subscribe and also share the link with friends. We go to part B. A bucket is in the shape of a frustrum of a cone. The base radius of the bucket is 7 centimeters. The bucket contains water to a height of 15 centimeters. The radius of the surface of the water is 10.5 centimeters. Find the volume of the water in the bucket. We are going to begin by sketching. So we can sketch. We have the bucket here. This is our bucket here, and we have been told the bucket contains water up to a height. The bucket contains water up to a height of 15 centimeters. This is the water here, and the height of the water is 15 centimeters. Then of course we have been told the base radius of the bucket is 7. We have a radius of 7 here. This is 7 centimeters. Then of course the radius of the surface of the water here is 10.5 centimeters. This is 10.5 centimeters. Now we need the volume of the water in the bucket. Remember, this bucket was extracted from a cone, and therefore we are going to extend this bucket so that we can obtain the cone from where the bucket was extracted from. We know once we have formed our cone, assuming the height of this smaller cone here is h. Now for us to get the volume of the water in the bucket, we must get the volume of the cone from this particular point, let me call it V, to this point here where we have the surface of the water. And from similarity and enlargement, if we take the bigger radius over the smaller radius, this must be able to give us the capital H over the small h. The bigger radius has been given, that is the radius of the water surface, as 10.5. We divide by the smaller radius, which has been given as 7. This one would be able to give us the bigger h, which is from this point up to this point. We have 15 plus h divided by the smaller h, which is simply h. We can cross multiply here. If you cross multiply, we are going to have 10.5 times h, giving us 10.5 h, being equal to 7 times 15 will give us 105, plus of course 7 times h will give us 7h. Collect the like terms, 7h comes to this other side, so 10.5h minus 7h will give us 3.5h, being equal to 105. Divide both sides by 3.5, h is going to give us 30 centimeters. Once we have the smaller h, we will be able to get the bigger h, and the bigger h is going to be the smaller h, which is 30 plus 15, giving us 45. Once we have the two heights, that is the height of the smaller cone and the height of the bigger cone, we proceed and get the volume of the bucket. To get the volume of water in the bucket, we simply take the volume of the larger cone, which is a third, pi r squared h. We are using capital R for the bigger cone and h for the bigger cone, minus a third pi r squared h, and this is the volume of the smaller cone, the one that we have just formed here. Having done that, we can now proceed. So we are going to have a third times 22 over 7 times the bigger radius. We have gotten it as of course 10.5. Since it is squared, we multiply by 10.5. We multiply by the capital H, which is 45, minus a third times 22 over 7 times the smaller radius, which is 7 squared, times of course the small h, which is 30. If you use your calculator here, a third times 22 over 7 times 10.5 times 10.5 times 45, this will give us 5197.5 minus the volume of the smaller cone, which is a third times 22 over 7 times 7 squared times 30. This one will give us 1540, and the difference between the two will give us 3,657.5 centimeter cubic as the volume of water in the bucket. We move on to Roman 2 of the same question. Roman 2 reads, the shot put ball is completely submerged in the water in the bucket. Calculate the new height of the water in the bucket. Remember, we are putting the shot put ball here, and we have been told previously that the shot put was spherical in shape, and therefore we calculated the volume. We calculated the volume of the shot put, which is 1047.6 centimeter cubic. So in this case, we know volume of shot put, which we calculated, was 1047.6 centimeter cubic. We are putting a shot put ball into this bucket, and of course the shot put is going to occupy the space, and therefore the water is going to rise a bit, giving us the new actual height of water in the bucket. So what do we do from here? We are going now to assume that the water is going to rise a bit by a height of, for example, y. In this case, to get the new volume first, we are going to take the volume of the water in the bucket, which is 3657.5. We add the volume of the shot put, which is 1047.6, and this one gives us a volume equivalent to 4705.12 centimeter cubic. Once we have the new volume, remember we can still use similarity and enlargement to get our new height, and we have already assumed the new height, or the increase in height, to be what? To be y. And therefore, to get the new height, we are simply going to take the height that we had initially of 45. From here to here, we are going to have 45. We add the increase in height. So this is our new height, which is 45 plus the new increase. And of course, so since the bucket does not operate on its own, we are going to extract everything from the cone. And therefore now, using similarity and enlargement, we know that we have been given the volumes. And therefore, if we have the volumes, we can use what we call the volume scale factor. And to get the volume scale factor, we are going to take the linear scale factor. Of course, we cube. How do we get the volume scale factor? The volume scale factor is obtained by comparing the two volumes. That is, we have the volume of the new level, which is 4705.12. You divide by the original volume of the bucket, which was 3657.5, and this one will give us the new height, which is 45 plus y over the original, which was 45. Having done that, if you take 4705.12 divided by 3657.5, you are going to get an answer equivalent to 1.2864, being equal to 45 plus y over 45. Remember, since this is the linear scale factor, we are going to cube it so that we can get the volume scale factor. From there, we are going to get the cube root on both sides. Cube and cube root will cancel. If you get the cube root of 1.2864, we can use our calculator. You come here, shift, then cube root of 1.2864. This one gives us 1.088, 1.088 is equivalent to 45 plus y over 45. If you cross multiply, that is 45 times 1.088, we are going to get 48.94 being equal to, remember, times 45, and 45 will cancel, such that we have 45 plus y. And in this case, to get y, 45 comes to this other side, such that 48.94 minus 45 will give us y, and therefore y will be equivalent to 3.9 centimeters. But remember, we have been told to calculate the new height. Initially we had a height of 15 centimeters and we have had a rise of 3.9, and therefore the new height, we are going to take 15 originally plus the new increase of 3.9, giving us 18.9 centimeters, correct to one decimal place. Thank you for watching and welcome to our discussions. And in case you are watching this channel for the first time, please take a second or two, click the subscribe button so that anytime we publish a video like this, you'll automatically be given a notification.